Hey, in this video, we are going to try and understand hybrid networking. So what is hybrid here? When companies have their workloads, their applications running across a private data center and a public cloud, it is called a hybrid cloud. That it might also be the case that these organizations and companies are running it on multiple public clouds, right? In which case it is called multi-cloud. Now, why would they be doing this? In certain cases, it might be that they are in the process of shifting to the cloud entirely. They might be abandoning and exiting their private data center, but obviously it cannot be done overnight, right? It takes time. And during that process, they want to ensure that both clouds, right, both environments are working consistently and well. It might be that in certain cases, they want to continue to retain their private data center, which has limited capacity, and any additional demand that comes in, maybe they want to put it on a public cloud like Google Cloud. Finally, in certain cases, there might be strict regulations that certain kinds of workloads, certain applications can only run within the private cloud, in which case you can't move that to a public cloud, right? So there are regulations, compliance requirements that does not allow a move to the public cloud. When that happens, when there is a combination of workloads in these two clouds, we want to have connectivity between them, obviously, right? In certain cases, we need high-speed, reliable connectivity beyond what is provided by the general public internet, right? Because there might be large amounts of data going back and forth. We also might have security requirements. And in certain cases, in the process of moving to the public cloud, initially itself, there might be a large amount of data transfer. Even as the applications are running, they might be communicating across the network, and therefore we want to continue to have high bandwidth. So on Google Cloud, there are 5 hybrid connectivity options: dedicated interconnect, direct peering, cloud VPN, partner interconnect, and carrier peering. We will look at what are the considerations on choosing one or more of these hybrid networking options. And there are 3 critical things that I consider are important for making that choice. One is the distance from the Google Cloud facilities, the need to share IPv4 address space following the RFC 1918, or whether they want to consume public services. And finally, the bandwidth requirements for that network. In certain cases, the bandwidth requirements might be low. In certain cases, it might be very high, right? So based on these 3 considerations, we will choose the kind of hybrid networking we want. Let's get in a little deeper now to identify the details with each of these criteria. First one, distance from Google facility. So one option, of course, to connect a private data center which is on the left, to the public cloud, which is Google Cloud in this case. One of the options is to just go over the public internet, right? So there is the internet is available for everybody. You make when you want to send something to Google Cloud, you go over the public internet and it comes back over the public internet. And this option is possible and available for everybody. Now, when we say the public internet, what does it mean, right? It's basically going over many ISPs. If, for example, you're sending some data from a US region to a region in Europe, it's probably going through local internet service providers networks, right? And there might be other networks also that it might be traversing. So when it goes to the public network, note that it goes over many different networks which are not entirely in your control. And the problems with that are that there could be what are called man-in-the-middle attacks. So, for example, if there is a datum going from here to here, a ISP or one particular network that is not reliable or trustworthy, right? Maybe they're acting maliciously, or maybe they have good intent, but maybe their security is low, and somebody's hacked the network and they're able to read this data. Then they will modify it, or they'll have this information which they really shouldn't have, right? So these are what are called man-in-the-middle attacks, where for data going from point A to point B, somebody's inserted themselves in between and is collecting, reading the data, modifying the data, whatever. The second problem, of course, is it could be slow, right? When you're going over the public internet, it might not be reliable. There might be an issue at the ISP. It might be going over multiple hops before it gets to Google Cloud, and therefore it might be slow. Similarly, it might be unreliable, and there will be limited bandwidth with service level agreements that might be offered by the public internet in general. And that becomes a bottleneck for high-speed data transfer between these clouds in a hybrid cloud setup. So we want something more reliable, more with better SLAs, and which is also going to be secure. One option, of course, is to just reduce the to remove the problem with the man in the middle attack. Right? Is to say, let's encrypt the data. So instead of sending this data in open, human readable, easily readable format across the internet, what you do is you encrypt the data at one point and you're able to decrypt the data only at the other point. So even if there is a man in the middle, even if somebody is listening to this information, they are not able to interpret it, right? Because it's all encrypted, it's all garbled in there. So they can't make sense out of it. So one way to continue to work over the public internet would be to provide a encrypted channel with the encryption endpoints being one within the private data center and one within Google Cloud. So obviously in this case we need encryption, and the other words you can remember when it comes to this is one, that it is virtual, right? There is no direct connection between these two data centers. Instead it is using the public internet, right? But the data itself is going to be private, right? It's encrypted. So it's virtual, and it's a virtual network, virtual connection that is provided, not a direct connection, and the data is going to be encrypted, right? So just keep that in mind. We will come back to these things later. The other option is to avoid the public internet entirely and draw a direct connection, right? Individual, a personal, what do you call it? Exclusive line between the two data centers, right? The private data center and Google Cloud. So if you're able to achieve that kind of a direct line, that would be wonderful, right? Because then you don't need to go over the public internet. But of course, what would be required for this? It would be required that these two become close in proximity, right? Geographically, these can't be spread over extremely long distances because it will be difficult to get that kind of networking. So in this case, there are two words you can keep in mind. Because it is a direct connection or a dedicated connection, those are words that will come up with respect to this kind of a single line, right, between these two data centers. So keep that in mind about dedicated and direct, and it will also require these to be in close proximity. The other option is, if you do not have proximity to a Google Cloud facility, the option would be to work with a Google partner, which would be an ISP, which has got its own connection to Google Cloud, and then you ride on top of that by making a connection between your private data center and the ISP, right? So you still are not traversing the public internet. Instead, you're going from the private data center to the ISP, and the ISP takes that with their own dedicated connection to Google Cloud, right? So with an intermediate ISP also, you're able to do the same thing. So the two words you can keep in mind in this case, right? One, we are working with a Google partner when it comes to the ISP, and ISPs are also called carrier, right? Carrier networks. So those are two words you can keep in mind for later on. In that case, of course, you still need proximity to an ISP, but then there's a larger chance that your ISP already has established a connection with Google Cloud, and you can draw to that, right? So your proximity to ISP is going to be higher. So based on just distance from Google facility, here are the options that we have learned so far, right? Both the dedicated and the direct, right, whether it's dedicated interconnect or direct peering, requires a connection to a Google facility, right? Now what the Google facility is, we'll come back to later. We saw that Cloud VPN was the one that is able to go over the public internet in an encrypted fashion, right? So it's a virtual private network, right? It is not a direct connection, it's not a dedicated connection. Instead, it is establishing an encrypted connection over the public internet, which is only readable at either end. With the two words partner and carrier, we are looking at an intermediate ISP that is going to connect to the Google Cloud facility directly, and your company, your private data center is going to connect to that ISP, right? So this is at a very high level. We haven't got into the full details yet, but we've established now that there are different options depending on the distance from a Google facility, right? How close are you to a Google facility? Then what are the wires you can draw from your data center to Google Cloud? And if you don't have that, you can go via a partner or a carrier. And if you can't do even that, you can go over the public internet and use Cloud VPN. So what kind of Google facilities can we connect to? For that, to understand that, let's just understand how data travels, right? If you have your mobile phone or your computer and you're going over the, you're working from home or you're somewhere outside, that's one possibility. The other possibility is that you're working from an office, right? So whichever be the case, very often from the end user, it goes to the public internet, and from the public internet, it is going to first touch a point called Google POP, or a point of presence, right? So for a lot of services that we use, like Gmail and Google Drive and all that, they have a endpoint that resides on the Google point of presence, right? So when you're using a Google service, it goes over the internet and connects to the POP. The POP in turn is going to have connections to the data center, and of course it is inside the data center that are running the actual computers that with the storage and the CPUs, which is going to store your data and process the instructions that you've given it, right? So that is how data travels between the end user and the final machine that does the work, by going via the POP and then to the data center and then to the virtual machine. And this applies for most public services that Google exposes. Now, the question is there a way in which we can avoid the public internet? So one way would be to go directly from end user to the point of presence, or we can even consider the option that the end user goes directly to the Google data center, right? So if there was a way to avoid the internet, these might be two endpoints that we can directly try to reach, which would make it safer, faster, and more reliable possibly. So let's look at that now. One option obviously is the private data center connect to the POP, right, the point of presence, and then to the Google data center, right? So there's a direct connection you go draw from the private data center to the Google point of presence, and obviously that is going to have a internal connection to the Google data center. The other option is for this private data center to skip the POP and go directly to what is called a Google Colocation facility, which is going to be alongside the Google data center, right? So in this case, you are not going to the POP and then going to the Google data center. Instead, it goes directly to the colocation facility attached to the Google data center, right? So those will be the two options when it comes to connecting to a Google facility, right? So just to step back a bit, private DC to POP, and the POP takes it to the Google data center, or the other option, go directly from private DC to the Google colocation facility, which is attached to the Google data center. So I didn't find this chart online, but I made this myself based on data that is available. And these, as you can see, are the colocation facilities available for customers to connect directly to a Google colocation facility, right? So it is going to be close to many of the regions that they are currently in. And there are quite a few of them, right? There are quite a few of them, and there are way more than the number of data centers, right? So you can connect to any of these points, and that will have a fast connection to the data center itself. So the first criteria that we saw was about distance to a Google facility, right? The second criteria we are looking at is shared private address space. For this, I would recommend that you see another video that I've done, Terminologies 001, which is talking about RFC 1918 and private addressing, right? So that goes into a little more detail. We're just going to briefly look at it so that you get the idea, but move on quickly from what is RFC 1918 itself. So the expectation from RFC 1918 is, or the standard established by RFC 1918 is that a certain set of addresses are available which are not going to be on the public internet, right? It's only going to be within a private network, and it can be reused by any number of organizations. Now, in this case, when we are using private addresses, sometimes we want to be able to share the same address space across these two setups, right? Between the private data center and the public cloud. In this case, this is A's private data center, and this is A's VPC within Google Cloud, right? So you can see that there is machine 001 here, and 2 here, 3 here, and 4 here. And they're able to directly address that, right? And that makes it convenient and easy. Whereas if you did not have this, then what will happen? There will be a 01 here and 02 here, similarly 01 and 02 here. And now these cannot directly communicate because there will be a conflict between the IP address, right? There is no uniqueness, and that becomes a problem. The way to solve that would be a little more complex. You can put a cloud NAT in front of it, and then the cloud NAT over here, and it interprets where the data has to go, where the data packet has to go. But in general, this becomes more complex, and it would be convenient to have just a shared address space so that 1, 2, 3, 4 exists in the same place. So, they exist across networks, but they are in the same set of shared addresses so that they can directly communicate with each other, right? So, if there was a machine or a node running here, it is able to directly access this without having to go through different kinds of translation, right? So, here, the idea is there a way we can again draw a wire of some sort, right, between these two data centers and to be able to connect these two, whatever be the way it is. One option, which is an interconnect option and which is called the dedicated interconnect, is when you are able to draw a line directly from the private data center to a Google Cloud co-location facility, right? As you can see in this case, it is sharing the same private address space, right? So there is 001 here, 002 here, and it is able to directly address the machines there. So it's not going over NAT and over public addresses, it is able to directly address that, right? So you can see again, when there is a exclusive connection, right, a single line connection between these two data centers, it would be like a dedicated or a direct one. So in this case, it is dedicated and it is an interconnect option, which means that there is private RFC 1918 addressing. Obviously, the two data centers or your private data center will have to be close enough to a Google Cloud co-location facility to be able to do this. In the option that you want to have private addressing, but you are not close to a co-location facility, then you can go via an ISP which already has a partnership with Google Cloud, right? So that partner interconnect will have a connection already established between that ISP and the Google co-location facility, and you can then connect from your private data center to that ISP. Even in this case, right, in the case of the partner interconnect, you're still able to have private addressing. In this case, it's obvious that you will have to have a proximity to the ISP's data center, but which might be more available. The earlier two options that we saw required us to have access to RFC 19 private addressing, right? Now, there are certain other use cases where we don't want that. Instead, what we want is to be able to access certain public services. So, say for example, Google Workspace services, right? So, if you're using Gmail and Drive and all that, you are not setting up Gmail and Drive within your own VPC, right? It's not a specific application. Instead, it is hosted by Google Cloud itself, and there are well-known published IP addresses where you can access Gmail and Drive, right? So, in this case, the well-known IP is published and you want to be able to connect to that open public address, right? So what would be one way to do it? Again, go over the public internet, right? So you can go from your desktop via the public internet to the IP address, the public IP address, which will take you to the Gmail service or the Google Drive service, right? So that's one way to do it. Now, even in this case, there might be a requirement for companies to say, you know what, we don't want to go the public internet. We want to have our own direct line, right? Our own exclusive line, so that all our employees can access these public services with higher bandwidth, higher reliability, higher security. Similar approaches are there for this, right? To get this kind of service. So in this case, since these are services that are hosted in general by Google Cloud across the world, you don't host it inside your own VPC, right? Instead, the point at which you connect to these services are going to be on the Google point of presence, right? And the Google point of presence has got hundreds of, or more than 100 POPs across the world, to which users directly connect, right? So in this case, what will happen is that you are going to draw a line between the private data center and the Google point of presence, right? So it's not directly to the colocation facility. Instead, it goes to the Google point of presence, and from there, of course, it is going to redirect you to the Gmail service or the Google Drive service. So in this case, the option is to go directly from DC to POP, and this is called direct peering, right? So the general option is called peering, and since you're drawing a direct line to one of the Google facilities, this one is called direct peering. The other option is when you do not have proximity to a Google POP, right? If you are far away, then what is the option? You work with an ISP who has an established connection to that POP. Right? So in this case, what you're doing is you go from the private data center via the ISP to the Google POP, which is where the endpoints for Gmail and Drive and all this, and it will be redirected to those services, right? So in this case, also like the previous one, it is a peering service that works at that connects first to the POP, and instead of going directly, you're going via a carrier, right? Via an ISP that is available, right? So the ISP or the carrier in the telecom world is called a carrier network. So it goes via the ISP and reaches the public services that are hosted by Google Cloud. Those would be the options when it comes to lines that you're drawing between your private data center, network lines that you're drawing between your private data center and either an ISP or a Google facility. In certain cases, none of this is available, right? You don't have proximity to a particular ISP, or you don't have a proximity to a Google colocation facility. You still have an option to go with a cloud VPN. The cloud VPN, as I said, it works over the public internet, but you get to have an encrypted channel with encryption on either end. And so that they can communicate without man-in-the-middle kind of attacks. The interesting thing about Cloud VPN is that it still allows private addressing, right? Even though you're going over the public internet in this case, it still allows you to have private addresses shared between these two locations, right? Between the private data center and the VPC within Google Cloud. Now, this is a very convenient option, right? There is no new lines to be drawn, no additional networking to be set up. You don't have to deal with setting up peering and interconnect and all of that. Instead, you just work over the internet like you would work with other services and just establish a VPN endpoint within the private data center and also within the VPC. And this is fairly straightforward, right? You can be up and running with this in a matter of minutes. So in those cases where you have none of the other proximity options, and you still want encrypted connection over the internet, over the public internet, VPN, cloud VPN is what you would use, right? The interesting thing again for it, you are able to have shared private RFC 1918 shared address spaces, right? So that is very convenient. So just looking at the options for private addressing versus public published IPs, right? The two interconnect options and VPN allow for RFC 1918 private addressing, whereas the peering options, they have only access to the public addresses. Yeah. One way to remember this might be that when you're looking at the word peer, right, there is another word, for, other meaning or other another spelling and meaning for the word peer, which basically means that that board that is jutting out into the lake or the sea, and then you're looking out into the public space, right? So a pier, you can think of it as if you're on a pier and looking into public space, right? And in this case, with the peering options, you only have access to public addresses, whereas the others you can in general remember that they have private addressing. So just a mnemonic to jog your memory about which of these options give private addressing and not or not. The third criteria would be bandwidth, right? This is fairly straightforward. If you have a dedicated or direct connection, you're looking at higher reliability, higher bandwidth, right? You've set up the line yourself, or connecting either to a POP or a Google colocation facility, and you've established a certain bandwidth for that line, right? So you get high bandwidth SLAs when it comes to dedicated interconnect and direct peering. Yeah. This is about 10 GB. This is 10 Gbps per link, and I believe you can have up to 8 links in parallel. Cloud VPN gives you about 1.5 to 3 Gbps per tunnel, and you can have multiple tunnels also. When you're working with a partner, right, when you're working with external ISP, obviously it is going to be dependent on what they offer, and the partner connection might go anywhere between 50 Mbps and 10 Gbps. In the case of carrier peering, there's not going to be any SLAs, right? So this is whatever the ISP provides is what you get, right? You don't have an SLA from the side of Google, right? If the carrier says, hey, we're giving a certain SLA, then that's what you will have, right? But it is not guaranteed by Google. Some mnemonics again to remember this. The two dedicated and direct ones both have 10 Gbps, and you can think of it as direct and dedicated has definite deca or decimal bandwidth, right? The deca or decimal meaning 10 and base 10 values. So this is reliable, this is fast, and they're all like in that D range. I mean, they're starting with the letter D, right? So that's might be easy to remember. Cloud VPN goes over the internet and it gives you 1.5 to 3 Gbps. On the partner interconnect, because you're going over a partner, it depends on the partner, right? So it can go up to 10 Gbps per link per connection, and it might be as low as 50 Mbps also. For carrier peering, there are no SLAs, and one of the ways that you could remember is, there are these things called carrier pigeons or homing pigeons, where you can attach a message to the feet of a pigeon, and it will take that message to a different place, right? So think of this carrier peering carrier pigeon, and the carrier pigeon doesn't provide a particular SLA, right? So that could be a mnemonic to just remember that the carrier peering has no SLAs, right? Just a convenient way to remember. So in summary, right, a few of the key criteria for deciding which hybrid networking option you can pick up, right? We can see with this. The direct and dedicated ones require proximity to a Google facility. In the case of a dedicated interconnect, it is a co-location facility. So one way to maybe kind of think about this again would be, I'm dedicated to my cool location, right? So I'm dedicated to my cool location, and that's a dedicated thing, and it requires a connection to a co-location facility. Excuse me. The partner interconnect also, it is going to connect to a co-location facility, but it is going to go via a ISP, right? So the dedicated and direct Google facility. Cloud VPN is just going to think of the cloud as the public cloud or the public internet, and it just goes encrypted over the public internet. Partner and carrier is going to go via an ISP, so all you need proximity is to the ISP itself. And of course, it depends. I mean, certain ISPs have that partnership with Google. Those are the ones you should be connecting with. When it comes to private addressing, the mnemonic you can think of is looking out into the public space from a peer. And the direct peering and carrier peering allows you to access services that have well-known published public IP addresses, while the remaining 3 allows RFC 19 private addressing. And when it comes to bandwidth, again, I've given you a couple of things that you can remember this way. Dedicated and direct, they have a deca or decimal bandwidth of 10 Gbps per link. And in the case of a carrier peering, there are no SLAs. You can think of a carrier pigeon that is taking a message and you don't exactly know when it is going to be delivered. Right? For the partner interconnect, you have a dependency on that ISP, so it could be between 50 Mbps to 10 Gbps per connection. Cool. So we've established what are the key differentiators between these options. And as a refresher, let me ask you a bunch of questions. So if your company data center is close to a Google colocation facility, which high bandwidth, high networking options are available for you? The two that you should be thinking of would be dedicated interconnect and direct peering, right? So when it requires a direct connection, dedicated connection, it's an exclusive line that you're drawing, and therefore it has to be to either a Google POP in the case of direct peering or to a Google co-location facility in the case of dedicated interconnect. If you want to access public services on Google Cloud, what are your options? Here the two options that you should be thinking of would be direct peering and carrier peering, right? It takes you to a POP, and those are where the established well-known address, endpoints or Gmail, Google Drive and others are available. If you need RFC 1918 private addressing, what hybrid networking options do you have? In this case, you should think of the ones that are not the public addressing ones. So the 3 that are available for you would be dedicated interconnect, partner interconnect and cloud VPN. If you want to have quick hybrid connectivity and you're okay with low bandwidth, what are your options, right? So in this case, we don't want to draw a line. We don't want to get into that setup. We just want to work over the public internet. That would be fine. In that case, the option you have is cloud VPN, which allows you to encrypt the data that is going between the 2 data centers. If you're not close to a Google facility, but still need exclusive connectivity, what options do you have, right? So you still want a certain amount of reliability and all of that, then the options are that you have to work with a ISP, right? So it's the 2 options there are partner interconnect and carrier peering. Here, of course, I have not specified that it is private addressing or public addresses are fine. But if you're working with an ISP, you'll be looking at the words for partner or carrier. Right? Those are the options available for you. If you find these videos useful, consider supporting me on Patreon or buy me a coffee. Also, don't forget to like, share and subscribe for more learning videos on Awesome GCP.